Module Overview : In modern land acquisition and development processes, environmental and land use suitability assessments are not just regulatory formalities. They are critical planning tools that ensure sustainability, compliance, and long-term viability of land-based projects. This module dives deeply into the environmental, ecological, socio-economic, and land use dimensions of site suitability analysis, guiding you through the comprehensive evaluation of a site's natural, man-made, and legal characteristics in the context of development potential. Land that is legally valid and geographically accessible may still be unsuitable for certain purposes due to environmental sensitivities, conservation policies, ecological risks, or physical terrain limitations. Conversely, a well-positioned and environmentally stable site may be restricted by incompatible zoning laws, community resistance, or fragile ecosystems. This module equips you with the skills and frameworks needed to analyze land from a multidimensional suitability perspective using empirical tools, technical assessments, and statutory guidelines. 1. Introduction to land use suitability. Definition of land use suitability and its relevance to planning relationship between site potential and development purpose. The principle of right use on the right land. Hierarchy of suitability. Highly suitable, moderately suitable, marginally suitable, and unsuitable land. 2. Environmental Impact Assessment, EIA. Overview and legal basis of EIA steps involved in EIA, project screening scoping baseline studies, impact prediction mitigation measures, Environmental Management Plan, EMP, EIA thresholds for different land developments, residential, industrial, mining, agricultural, role of regulatory bodies like NESRIA, FEPA, and state environmental protection agencies. Third Strategic Environmental Assessment, SEA. Difference between SEA and EIA-CA as a proactive planning tool for policies, plans, and programs. Importance of SEA in regional master plans, urban development zones, and eco-sensitive areas, SEA process, indicators, and stakeholder engagement. 4. Physical and ecological suitability analysis. Evaluation of soil quality, loamy, clayey, rocky, acidic. Slope gradient and erosion risk, vegetation cover, and biodiversity zones, hydrology, water, tables, flood risks, drainage, seismic and landslide risk zones, mapping techniques using terrain models, GIS overlays, remote sensing. 5. Zoning compatibility and legal land use categories. Zoning categories: residential, commercial, mixed use, conservation, agricultural, green belts, interpreting local development control guidelines and urban planning regulations, compatibility checks between proposed use and legal zoning designation, consequences of zoning violation, denied permits, fines, demolitions, litigation. 6. Socioeconomic and cultural suitability. Consideration of indigenous land values, cultural heritage sites, sacred groves, impact of development on local livelihoods, displacement, land tenure systems, community resistance or support based on prior land disputes or historic events. Tools for social impact assessment, SIA. Carrying capacity and threshold analysis. Understanding a site's carrying capacity to host development. Environmental thresholds for waste, water, energy, and traffic. Urban heat island analysis and climate adaptability. Site resilience modeling under climate change projections. 8. Land suitability modeling and ranking systems. Multi-criteria, decision analysis, MCDA. Analytical hierarchy process, AHP, weighted overlay using GIS tools. Scoring land based on suitability indices, integration of expert judgment, stakeholder input, and empirical data. 9. Sustainable site development principles. Eco-sensitive site planning, green infrastructure integration, natural drainage and permeable surfaces, preserving natural buffers, trees, and riparian corridors, avoiding ecologically sensitive areas, e.g. wetlands, forest reserves. Learning outcomes. By the end of this module, you will be able to Understand the role of land surveying in the acquisition process. Read and interpret professional survey plans. Identify boundaries using coordinates, GPS, and cadastral maps. Use GIS tools for spatial analysis and planning alignment. Understand drone and remote sensing technologies in modern surveying. Verify accuracy of land shape, area, and position using geospatial tools. Learning outcomes. By the end of this module, you will be able to conduct land use suitability analysis using environmental, physical, and socio-economic criteria. Understand the EIA and SEA process and their regulatory significance. Apply GIS and remote sensing for land evaluation. Analyze risks and opportunities based on ecological and planning indicators. Integrate sustainability principles into land development decisions. Prevent environmental degradation and ensure land use compliance.